So let's continue for more examples from the book. We have question number 2 here. Have this differential equation y double prime plus 2y is equal to 0, and we're given these initial conditions. We start off by writing out our characteristic equation. So we start out by writing our characteristic equation. I'm going to abbreviate here. R squared plus 2 is equal to 0. So r squared is equal to minus negative 2, and r is equal to plus or minus the square root of 2i. And if we write down our general solution, we're going to have y of t is equal to c1 cosine of the square root of 2t plus c2 sine the square root of 2t. So we have our general solution. But before we can start plugging things in, we need to differentiate our general solution, because all of our initial conditions are given in terms of its derivatives. So if we differentiate our solution, we're going to have negative square root of 2 c1 sine of square root of 2t. And notice that here I'm using the chain rule. This is why I pick up a factor of square root of 2. So you need to multiply this out. And here is the same thing. Using the chain rule, we're going to have a square root of 2 c2 cosine of square root of 2t. Alright, so here's what we get. Now we can start plugging things in. Now we can start with our left boundary condition. Our left boundary condition says that y prime of 0 is equal to 1. So let's plug this in. So negative square root of 2 c1 sine of 0 plus square root of 2 c2 cosine of 0, that is equal to 1. Here we notice that sine of 0 is equal to 0. So this term vanishes. And we have cosine of 0 is equal to 1. And therefore c2 is equal to 1 over the square root of 2. If we divide both sides by the square root of 2. Now let's talk about our right boundary condition. So our right boundary condition is y prime of pi is equal to 0. Y prime of pi is equal to negative square root of 2 c1 sine of pi square root of 2 plus square root of 2 c2 cosine of pi square root of 2, right? That is equal to 0. So we know what our c2 is. If we want to plug this in, I'm just going to erase it here and plug it in, which is 1 over the square root of 2. So the square root of 2 cancels out in this term. And if we're going to solve for c1, we're going to get that c1 is equal to 1 over the square root of 2 times the cotangent of pi square root of 2. And this we get by, if we subtract this cosine of pi square root of 2 on both sides, this is going to become negative. So the negative with the negative is going to become positive. And dividing both sides by this, we're going to have cosine divided by the sine, which is just cotangent. So this is what we're going to get for C1. So we have C1, we have C2, and our boundary, so our solution to our boundary value problem is this. I'm going to erase this part of the board. I'm going to erase this part of the board where it's not relevant to write out our boundary value problem. So here, this is our general solution, and these are our constants that we got. So we can write the solution to our boundary value problem as y of t. Let's factor out this 1 over square root of 2, because we can see that we have it on C1 and C2. We have this factor of 1 over square root of 2. So if we just factor this out beforehand, we have 1 over the square root of 2 cotan of pi square root of 2 times the cosine square root of 2t plus 1 times sine of square root of 2t. So it is just going to be sine of square root of 2 times t. So this is going to be our solution to our boundary value problem. Alright guys, I'm going to keep this video short because it's easier to upload them to YouTube. So I'm going to be posting one more example like on these simple 2-point boundary value problems, and then we're going to go to ones that have like unknowns that it's a little bit harder to solve. But alright guys, I'll see you next time.